So it should be my colleague T, but actually, due to the visa issue, he cannot make it. So that's why I'm here. First, I'm the co-founder for Quark Chain and e-storage, and today I'm going to introduce EIP-7907. Increase the contract code size limit with gas metering. Sounds pretty technical, but since I'm not an engineer, so I'm trying to explain everything in the pure language. So first, a little bit about the team and us. So as I mentioned before, so we jumped into the area in 2018. Before that, I was in Wall Street and also in Silicon Valley for data science and the PM, graduated from Johns Hopkins. And C, which is the founder for e-storage and Quark Chain. So he got his PhD from Georgia Tech, and he's very active for the Ethereum ecosystem. So he's a co-author for this topic. 0797, and also you can see the author for a lot of EIPs. So he's in Facebook and Google. So we graduated from the same university before. And what is e-storage? Basically, it's a module and decentralized storage layer for the whole Ethereum ecosystem. It can be a layer 2 for the layer 1. It also can be a layer 3 for all the other layer 2s. And also, it's specified for programmable key value storage, powered by the data availability. Before that, so we are actually beginning our journey from Quark Chain. It's layer 1 using state sharding technology, because at that time, Ethereum is trying to do the state sharding. And then it pivoted into a layer 2. So working with e-storage for a new layer 2 called Super World Computer. So what we are trying to do here is to function as an experimental platform for Ethereum and OP Stack. As you can see, we did a lot of research, including this 0797, and also like the Zhou gas token, which I'm going to explain tomorrow. It's also like OP new features. So Web3 Access Protocol is a decentralized HTTP, and also leverage e-storage as a layer 3. So everything is kind of like new features. We just want to experiment in the new layer 2, and so others can implement that later. And those are all the research areas we have been working on. For example, in the layer 1 scaling, so 7907 is one of that. And we did the Zhou gas token is how to, just, shorten the way for Web 2 users into the Web 3. Web3 Access Protocol, some of them may already heard about that. So it's a decentralized HTTP, hosting everything fully on-chain. The data availability, so we got grants from the Ethereum Foundation, also OP Stack. We did some parallel EVM, and also the advanced fraud proof. We are also the core contributor for the Ethereum Portal network. Yeah. So if you're interested in any of the topic later, so feel free to contact me or the team. Okay, let's back to the topic. I'm going to introduce everything from the fourth section. What's the motivation for doing the 7907? What's the real, EIP 7907 looks like? And how do we implement that? And some summary for that. Some of you may know or might not know. So before that, so there's like a EIP called 170. So before the EIP 170, there's no code limit size. So, but everyone knows, so a resource of calling contract, including CPU, storage, whatever, it's linear according to the contract size. That means if your contract size is bigger, you definitely will use more resource. But according to the Ethereum design, no matter how big the contract is, it will always cost the same gas fee, that is 2,600. So how to understand that? So think about, so we are taking a Uber ride. We go to a nearby place, we go to a very far away airport, but the cost is the same. We know that definitely not possible because the Uber driver have to spend more time, have to spend more oil if the distance is further, right? But according to the Ethereum design, you will always charge the constant gas costs. So in that way, it's very easy to cost a DDoS. So let's do a rough calculation. If we want to deploy a contract with size 256 KB. Do you know how much the data it will generate in one block? It's about 2.8 gigabyte data. And that will take about 12 seconds to reach the consensus, because usually we reach the consensus in 1 second. So the EIP-170 jumped out, and it introduced the 24 KB limit of the contract size to avoid all those DDoS. So it says, okay, if the contract size is more than 24 KB, you cannot implement that. As a result, we can do a rough calculation. So basically, the code read from the storage, it will limit it by the 270 MB, much, much, much smaller than the 2.8 gigabytes data before. But that also has some issues. So as time goes by, there has been more complicated, like the app came out. So we know the DeFi Summer, we know the DEX, we know a lot of more complexity, from the code needed. So basically, the contract size becomes bigger and bigger. It's definitely more than 24 KB. So basically, if you want to deploy something, you have to follow EIP-170. You have to break down your big contract size into some small contract size. Otherwise, you cannot deploy that. But there have been a lot of pain point for the developers. So what is that? So definitely it will increase the maintenance cost, and it will introduce very complex ability for the code and even some security concerns. So as you can see, if you want to deploy like a large contract code, you have to break that into some small one and then deploy that. So that's why, naturally, we want to have a new EIP-7907. So basically, two things. One, we want to remove the limit of 24 KB. But still, because of some other constraints, there is some up limit. So we set a limit of 256 KB, and as you can see, I think it's bigger enough for the current needs. And what's next? Remember I said, according to the Ethereum design, it will charge constant gas. If we charge constant gas, then the DDoS is not avoid, right? Because so if you go to like a longer place, you deploy a bigger contract size, the cost is the same. So definitely the structure is wrong. So we want to, instead of charge everything the same cost, we want to introduce a dynamic gas metering cost. But trying to make everything compare with before, so we had such design. If the code size less than 24 KB, it will exactly as what we before, which is always the same cost as 2600. If it's bigger, then it has to has some exit gas. So how to calculate the exit gas? So there's a function for that. Basically, the original gas cost is 2600, and then so we will calculate what's the actual gas you have to pay. So in that way, you will definitely pay more if you want to deploy a bigger contract. So EIP-7907 is already choosing as a candidate for the next Fusaka upgrade. So how do we implement that? This is what we did before. So during the old EIP-170, as you can see, so you always pay the same gas, so 2600. So we will check whether the code size is less than 24 KB. If it's greater than that, refuse. If it's yes, okay, continue. After we have the 7907, so something changed. But the reason I put the wrong case here is you have to be very cautious. So even you said, okay, so we have a dynamic system, you are going to pay more if you deploy a bigger contract size. The wrong way is you read the whole code before you decide how much you should pay. Because if you already decided to read the whole code, that already introduced the DDoS attack. So what's the right way? So always just get the code size before you read everything. What does that mean? So I still will take Uber as like an example. So when you just had another request to go to the airport, instead of, okay, let's just driving there, so you need to estimate how much it will cost and ask the customers pay you first, and then you begin the ride. So that's the right way. So remember, always get the code size, get the estimate like gas cost before you begin to do everything, read the whole account. So that's the right way. So definitely there is like more ways of implementation. There already been a lot of discussion in the Discord channels. For example, one is the cold and warm state. What does that mean? So basically the EIP-7929 saying like, you don't need to pay, twice the same gas cost if you visit the same contract. So the first time you pay $2,600, and the second time you just need to take 100 gas if it's the same call, and you just don't need to repeat everything. And we put that into the EIP-7907 as well. So basically that will helping us to reduce the gas costs. As I mentioned before, so right now there has been a live discussion in the Ethereum R&D Discord channel. So if you have interest, feel free to join that. There has been a lot of suggestions for how to implement that and what should we do before the next upgrade. And also, so there's the details about the EIP-7907 and what's the old, because it's based on the EIP-170, and also so we using something from the EIP-2929, so I put everything here as well. Oh, sorry. So this one, we need to give some credits for a lot of people here. So without their help, this cannot be done. Also, so Zhou will have another technical talk pretty soon. So if you're interested for any technical details, feel free to listen to this talk. And also, you can contact me or him directly, and also can just follow us for the website. Yeah, so that's pretty much everything. Thank you.
I think we have quite some time for questions. I know it's very technical, but hopefully there are enough smart people here to be able to ask questions.
Yeah, we can talk later as well, because I will be here for 3 days. Thank you, guys.